Let's look at the graph you should have drawn. Now, everybody might be using different graph paper, so you might be using different scale, but it should look roughly the same. Time should be on your x-axis here, speed on your y-axis. I've gone up in 5s on my y-axis and 10 on my x-axis, but you just need to use something that fits. But what you should get is all the points, when plotted, should lie on a straight line that is descending as you go from left to right. Now let's try and answer the question. So I think the first one has to describe the motion. If we look at this, we can see, I mean, even from the table of results, you can look at it starts off at 50 and the speed starts getting less. So I think the keyword you want in your answer is either decelerating or maybe that it's slowing down. Okay, the speed is getting less as time goes on. So if this is a car, it might be hitting its brakes. Okay, it then asks what is the car's speed at 22 seconds. What I need to work out is if I look at this axis, you can see from here to here is worth 10 seconds, but I only have 5 squares in there. So if I divide that 10 seconds by the 5 squares, it means that each of these smaller squares is worth 2 seconds. So this point here would be 22 seconds. So what I need to do is, and I'll do it in a different color, take my ruler and draw a line up at 22, roughly about there. It's quite faint, I'm a little bit off, but it'll do the job. And do the same thing then where it hits this line, and we're getting that it is at about, well, this is 35, so there's 5 meters per second between there, and there's 5 squares. So therefore each of those squares is worth 1. So if we do 35 here, this is 36, 37, 38, and that's at about 39 if I've drawn it properly. So the answer to question 2 is it is traveling at about 39 meters per second when the time is 22 seconds. Question 3. At what time was the car speed 32 meters per second? We do the same thing here, except we go to 32. Remember, each square on the y-axis is worth 1, so that's 31, 32. Draw a cross with our ruler. Something like that. Draw it down with the ruler then. Somewhere about there, roughly. And we're getting that is 30, there's 32, there's 34, so that's going to be closest to about 36. So this one here would be 36 seconds. And finally, how much did the speed decrease each second? Now, what we can look at here is between the start, so 0 and 50. If we read up at 50, I'll just do it rough hand, because I can actually take that data from our table because all these points lie on the line. After 50 seconds, the speed is 25 meters per second. After 0 seconds, so at the start really, the speed is 50 meters per second. So the speed decreases by 50 meters per second in 50 seconds. Now, we want to find out how much it decreases by each second, so we divide the 50 meters per second by the 50 seconds, and it tells us it decreases by 1 meter per second each second. Now, those of you that have been paying careful attention should recognize that when we describe how much something slows down or speeds up each second, that's just acceleration. So in fact, what we're working out there is the acceleration, or in this case, deceleration of the object. So it decreases the speed by 1 meter per second each second.